Hey, algebra. So let's start out with the do now. We're familiar with PEMDAS, and you're probably also familiar with the fact that I change it to GEMDAS at every opportunity possible. What does that G stand for in GEMDAS? Go ahead and hit pause so you remember what that is, and then we'll join back together. All right. Well, the G is for grouping as compared to the P in PEMDAS, which is for parentheses. So parentheses are a form of a grouping symbol, but they're not the only kind of grouping symbol that we see in algebra. So we do use parentheses. You can see I started a little list over here on the green side here. We do use parentheses, but we also use other symbols like these vertical lines that we're going to learn about today. We use division, even if we did not have parentheses as part of that problem. Still means exactly the same thing. That big fraction line or division line groups together the things on the top. And there's a number of other symbols that we use. I'm not going to list them all here. So today we're going to look at absolute value equations. And our goal for what we're going to learn is that you'll be able to evaluate absolute value equations today. So evaluate comes from the root word value, which we could think of as just meaning a number. So our goal, our target when we're doing a problem, our ending point is we're going to come up with a number, and so not equations or graphs or anything but just what number does this equal, right? So in order to work with absolute value, a lot of the problems we're going to look at today use function notation. So I want to first do a quick review on function notation. Function notation we have done in the past is a way actually of using parentheses. Speaking of PEMDAS, it's a way of using parentheses that actually has nothing to do with the order of operations. So when we're given function notation like f of x, those parentheses do not indicate multiplication, does not anything to do with order of operations and when or what we're doing here. It's just communicating to us that this represents a function, which is a super important topic in algebra and other advanced math courses. And we've got right above that our specific directions for this problem. We are to evaluate the given function in yellow for the value f of -3. So inside those parentheses, that -3 is the input value. We think of that as like the x a lot of times. And so in green, the f is telling us which function to use. It might be that we have multiple different functions and they'll have different names. One could be called f, one could be called g, one could be called h, and so on. So we're supposed to use the one that's called f. That does tell us also that this is a function. It's the notation. It doesn't have to be the letter f. It still would be in a function. And when we are doing our work, we're going to use -3 as our input value. So we're going to put that into the x spot in that yellow version. So let's go ahead and substitute that -3 into the x spot. And now we do need to follow the order of operations, not because of the parentheses, but because we've got multiplication and subtraction. So we need to multiply first. So 7 times -3 is -21. Then subtract. So -21 minus 5 is -26. And if we wanted, we could bring down, just for the sake of clarity, we could bring down that original green statement to label what we have done. So if someone were only to look just at this bottom line of our work, this contains like absolutely everything we've done. It says, hey, we used the function that is named f. Our input value was -3. This is a function, and our final result when we evaluated was we came out with -26. So I mean, you could just write -26 and that would be clear also, but no one would know where that came from or how you got there. Okay, so function notation is going to show up today, but not exactly in that form. So let's look at absolute value. So absolute value has a notation. It's these two vertical lines you see around the x that I've highlighted in yellow there. Those are the symbol for absolute value. So if I put an x inside there, that means the absolute value of x. And that's what we call it. And absolute value refers to the distance between 2 points on a number line. So if we're thinking about a number line, we got 2 points on here. I want to know how far apart is the red and the blue dot. We just count, right? So you can bring a little graph walker over here to help us out. If you start on the red dot and you walk over there to the blue one, 1, 2, 3 spaces, right? So we say, well, it's a distance of 3 spaces. You could just do that visually. What if you started on the blue dot, though, and you had to go the other direction to get to the red dot? Would that make any difference? 1, 2, 3. Do we call that -3? No, we don't. Distance is always positive, right? And it's kind of an anecdotal proof. You think about measuring distance, we usually use something like a ruler, a tape measure, something like that. And there are no negative numbers on a ruler, right? I can make this end longer. I can get more numbers, but I can't make negative numbers show up on this ruler. So if I needed to measure starting at the blue one and going to the red one, I could switch, I could flip the ruler around, but it still is only going to show me positive numbers. Negatives don't ever show up on rulers because distance is always positive. And so that's why we don't put negative numbers on rulers. It doesn't even make sense. So absolute value is a symbol that tells us we're measuring distance. Okay, but there are not 2 points in this example up here. The absolute value of x, there's just an x, right? That's not 2 points. So how do we get distance between 2 points? Well, that's going to show up a little bit later on. For what we're looking at today, just to get started, absolute value is going to be used by itself. Just a single thing inside the absolute value symbol. It might be a single number, like absolute value of 5. It could be a variable, like up here, we've got the absolute value of x. It could even be the absolute value of an expression. But we're going to have to do with the expression. We'll have to evaluate that first before we do absolute value. So when used by itself, absolute value means the distance from the point 0 on a number line. So if I illustrate the second sentence here, my second point is 0. And so then my little graph walker can start on the point 5, and we would just count how many spaces away from 0 on the number line is that blue dot 5, where my graph walker is at. And it's 5 spaces away. All right, well, what if we change the question to the absolute value of -5? If I move this dot over here to -5, I bring my graph walker with me, switch the ruler around, that is still 5 spaces. We don't actually need the ruler. You can just count. There's 1, 2, 3, 4, 5 spaces on the number line. So regardless of whether you're at +5 or -5, it is still 5 spaces away from 0. And so a lot of times what people think of as the meaning of absolute value is these lines just mean write the positive version of the number, which is not wrong. It's a little bit oversimplified, but it totally works. Right? So anything inside the absolute value, you just write it down as positive. Okay. And that only works if we're dealing with a single number inside the absolute value. If you've got like an expression or something, we're going to have to do it a little bit differently, but we'll come to that in just a minute. So let's think about an extension. If I told you that the absolute value of x, some mystery number, is 3, and I ask you, what is x? You'd say, well, I don't know what x is. X is a mystery number, but I know that the distance from that mystery number to 0 on a number line is 3 spaces. So let's bring these things down here to help out. So that means if my little graph walker was to start at 0 on the number line, we would go a distance of 3 spaces away, and that would tell us where our mystery number is. Right? So you could either go 3 spaces towards the right, or our little number line walker could go 3 spaces to the left. So there would be 2 possible answers. Both of those 2 dots have a distance of 3 spaces away from 0 on the number line. So in this case, we have 2 answers, x equals 3 or x equals -3. Okay, that's kind of going to set the stage for some things we're going to look at a little bit later on. That's not going to show up today, but it's an important idea to keep in our brains, not too far towards the back. So let's look at what we're actually doing today. We're going to evaluate. So evaluating absolute value. So here's an absolute value expression. It's been written in function notation. So we're going to do this the same way that we did the earlier example with function notation. We're going to start with this yellow version. That is the function f of x, the function based on x, equals the absolute value of 7 minus x. We're asked to evaluate f of 5, which means I'm going to take 5 as the input value. It's going to replace the x in that original expression. So absolute value 7 minus 5. Okay, so these absolute value symbols do the job of grouping symbols. Is what we talked about back in the do now, right? Grouping symbols. Absolute value lines are a grouping symbol. And so we're going to have to do everything inside those symbols first before we apply the meaning of absolute value, which is to find the distance. Okay, so they're like parentheses. They do everything that parentheses do, but they also do more because it still means distance, and distance is going to have to be positive. So we're going to do the subtraction that is inside those absolute value lines. That has to happen first. 7 minus 5 is 2. And then we'll say, all right, how many spaces away from 0 is 2 on the number line, and is 2 spaces. So there's our final answer. It'll just be positive 2. Using that same function, let's look at a different example. Let's evaluate f of 10. So it means we're going to use 10 as our input. 10 is going to take the place of that x. And 7 minus 10. Okay, so I have to do the subtraction, which is inside those lines. That has to happen first. So 7 minus 3, that is negative 3. And then I can do absolute value. Absolute value means distance. How many spaces away from 0 is negative 3 on the number line? Well, it's going to be 3 spaces. Doesn't matter which side of the number line I'm on. I'm just counting how many spaces. So my answer is positive 3. Okay, what about a slightly more complicated example? Not a lot more complicated, but just a little bit. So here's a different function. F of x equals the absolute value of 2x minus 4. This time we are going to evaluate with negative 3. So I'm going to put that negative 3 into the spot of x, and that will have to be multiplied onto the 2 to negative 3 minus 4, and then the other absolute value. Okay, so I need to do the multiplication first. I'm just using parentheses in this sense to keep track of the negative 3, so I don't get confused and think it says 2 minus 3, but I'm multiplying here. Okay, so 2 times negative 3 is negative 6, and then I'm going to subtract the 4. Make those absolute value lines look like absolute value lines, otherwise they get confusing and look like ones. So inside those absolute value lines, subtract negative 6 minus 4, it's negative 10. And then I do the absolute value of negative 10. It is 10 spaces away from 0 on the number line. So final answer, positive 10. Okay, here's what sometimes people do. Here's I want to demonstrate what not to do. Sometimes people will say, look, I need to make this negative 3 into a positive number because it's going inside the absolute value, and absolute value means positive. And so people just say, make it positive. Okay, well, that would be a mistake if we do that too soon. We don't actually do the make it positive thing until we have done all of the operations that are inside. So let's just compare. We did f of negative 3 already. Let's do f of positive 3. Let's see what happens. We shouldn't get the same answer. So 2 multiplied by 3, and then subtract 4. There's my other absolute value line. So multiply 2 times 3, that is 6. And then I subtract the 4, 6 minus 4, that is 2. And so the absolute value of 2 will give me a final evaluation of positive 2. So I got very different answers. With f of positive 3, we got a final answer of 2. But with f of negative 3, I got positive 10. Right? It's not going to be the same if I just say, oh, this one says f of negative 3. I'll just put positive 3 in there because absolute value means positive. Right? The evaluation doesn't come out the same for the expression of this function. All right, so we have to keep the input value the same and don't just say, well, it's going to be positive. That doesn't happen yet. All right, last example. What happens if part of the expression is inside the absolute value and other parts of the expression are outside of those absolute value lines? Well, that's fine. This 4 is being multiplied by the group. So absolute value symbols are a way of grouping things together. It's not the same as parentheses because they do more stuff. There's an additional meaning to absolute value than what parentheses have. Also, there's a difference. With parentheses, you could distribute the 4. You could multiply the 4 onto both terms that are inside there. With absolute value, that would be a mistake. So we're not going to take something that's outside of the absolute value and multiply it in, because we're doing different things to these parts of the expression. Everything that's inside those absolute value lines, we're going to have to evaluate and then make it positive. But that 4 on the outside, that doesn't happen to it. Right? And so things are going to work out differently if we were to multiply that 4 into the parentheses. And so we want to avoid that. We're not ever going to distribute into absolute value. So this is going to look like 4 multiplied by the absolute value of 2 times -3, subtract 3. Okay, so we're going to start inside the absolute value symbol. Catch up on my highlighting. So 2 multiplied by -3, that is -6. Then subtract the 3. So -6 minus 3 is -9. Okay, at this point, I have to do the absolute value of -9. All right, I've done all the operations inside the absolute value, but now I need to actually do what absolute value means, which is to find the distance. So -9, how many spaces away from 0 is that on a number line? Well, it's 9 spaces. So I'm going to not multiply 4 by -9. I'm actually multiplying 4 times +9. And once I've done the absolute value, I don't need to keep writing the symbols. I did that part. Just like an operation, after you subtract, you don't keep writing down the minus sign. Right? After I've done the absolute value, I don't keep writing down the absolute value symbols. So I've done the absolute value to make this into a +9. Now I can multiply. 4 times 9 is 36. All right. Just for the sake of completeness, let's look at one last example. Let's take the same function that we just evaluated for -3, and let's see what will happen if we instead evaluate it for +3. So same function, this time +3 is going to go into the input spot. So we're going to have 4 multiplied by 2. 2 gets multiplied by 3, and then we subtract 3. Okay, so multiplying inside here first, 2 times 3, that's 6. 6 minus 3 is 3. The absolute value of 3 is still 3. 3 is 3 spaces away from 0 on the number line, so we can just multiply 4 times 3, which is 12. So that's the same answer we got before with the -3 as our input. No, last time we got 36. So just to repeat, you do not change an input value like an input of -3. Do not change that to positive just because you're putting it inside absolute value. We've got to follow the order of operations inside those grouping symbols first. So grouping symbols mean do all the stuff possible inside of those symbols, right? A lot of times we misunderstand and think grouping symbols mean, oh, distribute or whatever. Okay, just because there's parentheses written doesn't mean you have to do something with that first. It's really what happens inside of that grouping symbol, whether it's parentheses or absolute value. And it is not the same answer with a -3 or a +3. So the input value is going to give us a different answer if it's positive or negative. So we don't want to jump to the conclusion. A lot of times people say, oh, it's a shortcut. I'll just do the positive input. But it's not going to be the same thing. All right.